Yo,
What's up? Is my mic working all right?
yeah, it's working fine.
Okay. Just want to make. I'm using my actual laptop other than that little tab. I'm gonna return that tablet. So I looked up the price of a Surface Pro 7 and everything I need on it. $1,200. Surface Go and having about everything I need on it. 750. Yeah. So did you see where Kennesaw released the thing to where you can withdraw now?
Yeah, without fail.
Yeah. Um, I got this thing that has a bunch of red text on it.
Yeah,
But yeah.
but I can't withdraw anyway.
Yeah, graduation dates are a mean thing.
Mm, it's not just that. If I don't have 12 credit hours, my grant and scholarship go down.
I think I'm in the same situation, but all right, you ready to go over those? I'm sure you're looking at the screen. You ready to go over these problems again?
Sure.
Or you got any other questions?
Huh?
I can't write on anything now, but you got any other questions?
I was wondering if you could also go over like graphing an equation, like going over all the things that she requires you to find before graphing.
Um, you got to get the critical point, or you don't. Oh yeah, you got to take the first and second derivative, and then you find where it's increasing, decreasing, and then you get the critical points, and you label the critical points, and it's a lot. I'd have to. I don't have anything prepared on here
Okay.
since I'm not using the tablet. I can't. That's what I don't like about not having a tablet. Anyways, but yeah, let's see.
I think if I join through my iPad, I can share my screen and you could see me writing.
Yeah, that should work. If you want to try that. If no one else is here, I mean, oh well.
How do I join from here? Oh, here it is. Teams. That's I. Okay. Let me. Okay. I had to leave through my laptop and it was echoing. Um.
Yeah.
Can you show the problems again?
What do you mean?
The ones that you had pulled up for me to do.
Oh, I thought you were going to show like a problem for.
Oh no, I was just gonna do the ones you had and just do them here.
Yeah, I could look on a textbook. Yeah, I got it all worked out. But yeah, this is pretty much the same that worksheet. I just did it all with a L'Hopital's rule. I did half of them. I'll say. Are you sharing the screen?
Oh no, I'm not. Oops, thought I was. Let me see.
Hey, Vanessa.
Hey,
Screen, Microsoft Teams. Can you see it?
I cannot.
Let me try that again. Share screen, Microsoft Teams, start broadcast. Three, two, one. How about now?
I'm seeing a screen, but it's just the screen of It's just hang on. Let's see what happens now. Can y'all see my screen?
Yeah, I could see yours.
yes.
I wonder if we can't share more than one screen at a time.
Okay.
Yeah, Microsoft Teams is still in development. You'd think they would have just made it like part of Skype. But, all right. Well, I'll just go through this. Vanessa, do y'all know what La Hopital's rule is? She went over extensively for an hour and 30 minutes.
Yeah.
Yeah.
Its main use, me and Andy found out its main use one Monday when I chose these problems, not looking at them and seeing how hard they were without La Hopital's rule. And so here we get the limit as x approaches pi of sine of 3x divided by 2x minus 2 pi. And if you plug in x, you get 0 over 0. So the main use of this is to do trig functions or ridiculously hard algebra things. It gets rid of it for us. So you just take the derivative of the top and the derivative of the bottom, and you plug in the x, and you get negative 3 over 2. So nice and simple. Oh, and by the way, I don't have the tablet anymore. Or I'm going to get rid of the tablet, so that's why it's like this.
Okay.
It wrote to, if I can't write a 3, I get mad. And here we have a case where you have to do La Hopital's rule more than once in order to figure it out. But as we start, I think I'm going to go through this too fast. Oh, did the first one make sense to y'all? Like where I took the derivative. This is a constant, so that just disappears. And that turns to cosine, and you get -1.
The first one is 2x.
Yeah, 2x.
Okay.
I'm going to post the worksheet. I did the first 7.
All right.
I'm going to post the worksheet on Teams. So y'all can like come and look at that, and then I'm going to have the video up on YouTube and just post it right there. And so y'all can watch that if y'all need the extra practice. So, all right. And here's the second one. Limit as x approaches pi of 1 minus cosine of 2x over x minus pi. You plug it in, you get 1 minus cosine 2 pi, which is 1, and you get pi minus pi squared, which is 0. So doing La Hopital's rule, we get a positive 2 sine 2x because derivative of cosine 2x is negative 2 sine 2x, but we change the signs, so it's positive. And then you do chain rule on the bottom, bring the 2 down, and then change that to a 1, keep the same, take the derivative of the inside, which is just 1 because that's an x right there. But when you plug in, you still get 0 over 0. So you do it again. That's a great thing about this rule. You just keep going until it eventually works or doesn't work. And if it doesn't work, then you did something wrong at the very, very, very beginning. But anyways, you do it again. And you keep the signs. You get 4 cosine 2x over 2. And cosine of 2 pi is 1, so 4 times 1 is 4, and over 2 is 2. And you get 2. Am I making sense?
Yeah.
Is this working out better than me? How am I getting?
Then
Hey, James.
Yeah.
I didn't know she joined. What'd you say?
Yeah, this works better than what we were doing before for limits.
I was drawing for like 10 minutes to draw 3. Yeah, that works way better. This does, at least. I'm getting a red thing on Teams, and I'm confused. Activity. Oh, she wants to join the team. Okay. There we go. All right, for number 3. See these problems get progressively harder? The limit as x approaches pi over 2 of 4x minus 2 pi over 2, or 2 pi squared minus over 1 over minus sine x. You plug in pi over 2, that simplifies to 2 pi. 2 pi minus 2 pi equals 0. Sine of x, or sine of pi over 2 is 1, so 1 minus 1 is 0. So you got a problem that's it's an indeterminate form. So you apply La Hopital's rule, now that we're fancy. So doing chain rule, bring the 2 down, keep the inside, and multiply by the derivative of the inside, which is 4. Then you take the derivative of 1 minus sine x, the 1's a constant, so it's 0. Derivative of sine x is cosine x, and keep your sign. You plug in pi over 2, it's still 2 pi minus 2 pi, which is 0, which drops that. And cosine of pi over 2 is 0. So you got to go again. So you take the derivative of this. 4 times 2 is 8. Distribute that to the inside. You get 32x minus 16 pi. 16 pi drops because it's a constant when you take the derivative. So that's why it's just 32. Yeah, because that's a x. It's to the first degree, so it just simplifies to 32. And take the derivative of negative cosine x, so that flips back to positive sine x. Plug in pi over 2, that turns into 1, and you get 32. Does this problem make sense?
Oh, I have a problem that I just looked at the new homework you posted for the Habitas, and I need help with it.
Okay, let me finish going through these.
Sure.
And James, you can send messages through Teams on the screen if you click the show conversation screen. You can send messages through here. It should let you do that at least. Yeah. That way we don't have to spam everybody else who isn't coming in. And I only got 4 more problems, so it's not going to be too long. And then y'all can ask questions, general questions or whatever. And this is the limit as x approaches negative pi over 2. So if you plug that in, cosine of negative pi over 2 times 2, which is negative pi, which equals negative 1. So 1 plus negative 1 is 0. Then negative pi over 2 is, or times 4 is negative 2 pi plus 2 pi equals 0 squared, so it's 0. Then we have a limit as x, or we keep the limit. I'm getting tired of saying it. I thought I erased that one. Apparently I didn't. Or the printer picked up something very light, apparently. You get negative 2 sine x plus, or negative 2 sine of 2x. Negative 2 times sine of 2 times negative pi over 2, which is sine of negative pi. It's 0. Because when you take the negative thing, go around this way. Go clockwise instead of counterclockwise. But then if you take the derivative here, you apply a chain rule. Good old trusty chain rule. Drop the 2 down. There should be a pi right here. I don't know what happened. It doesn't change the answer though. Keep the inside, multiply by the derivative. But if you keep 4 pi or 2 pi, negative 2 pi plus 2 pi equals 0. That should be it. Let's see if I can draw with. That's not too bad. So there should be a pi right there. And that's a multiplication sign, but it's still 0, 0, so you go again. There's one of these where I went like 4 times, I think. Or maybe I'm just joking with myself. So you take the derivative of this, do chain rule with the sign again, you get negative 4 cosine 2x over 32. Cosine of negative pi, when you plug in that, is negative 1. Negative 4 times negative 1 is 4. Keep the 32 on the bottom because when you that's 8 times 4 is 32. That drops because it's a constant. 32x and 32. It changes to 1/8. Then, oh yeah, and that's that one. Yeah, here's a funky one. Sine cubed of 3x over 2x cubed minus 5x to the 4th. I think in the future I'm going to like write these out and then have y'all try to work them out and then go over them. Because I'm flying through this. And if I knew I was going to fly through it, I would have worked out all of them. But you plug in 0, you get 0 over 0. So you got to take the derivative. So you take the derivative of this one. It's just chain rule. Bring down to 3, keep the inside, multiply by the box right here. Or take the derivative of the box, you get cosine of 3x, take the derivative of this, and you get 3. But if you plug in 0, that's a 0, and it still makes all this 0. Then down here, you plug in, you take the derivative, you get this, and it's still 0, 0. So you got to go again. Can anybody guess how you take the derivative of this?
Do you have to do u prime v plus v prime u?
Yeah, that and chain rule. I think with this one, I'm not gonna lie, I think I used Mathway because I was getting lazy. But here, yeah, I use Mathway. I think that would be good practice for y'all, deriving that and that. This is actually a really good problem for L'Hopital's rule, and why it's really good to understand. If taking the derivative of this, you end up with this function. Unlucky for us, that turns in this sign turns into 0, and this sign right here turns into 0. So it's still 0 on the top, and you still got an x, and x down here, so it's still 0. So the whole goal of this is to keep taking the derivative until we get rid of a sign in one of the terms. And lucky for us, it happened in the next one. Otherwise, we'd have to keep going. You can take the derivative of this. You get negative 567 sine squared times 3x times cosine of 3x using the product rule. And over here, and then simplifying some more, you get positive 162 cosine cubed of 3x. Over 12. I did this on a program. I didn't get all the steps. I probably should have wrote down all the steps thinking about it now.
Okay.
But yeah. And down here, you get rid of one of the x's. So it helps you out there. Yeah, I wish I would have wrote down the steps. This would have been really good practice. If y'all feel like not being lazy, try this problem. This is a test problem, like a open answer test problem. Anyways, if you plug in 0, this whole term turns to 0, this turns to 0, so you end up with 162 over 12, which simplifies to 27 over 2. But yeah, this is a test problem. I wish I could write. Is everybody else good? That's here? Vanessa, James?
Mm-hmm.
So far? Okay. It's not bad yet. Oh, this one's super easy. Limit as x approaches infinity of 3x times sine of 2 over x. So you plug in infinity right here, and you get 3 times infinity, which is just infinity. And sine of 2 over x. When x is approaching infinity, sine of 2 over x is approaching what?
0.
0. And what's the sine of 0?
0.
Yep, that's right there. So it's just 0. So I figured that'd be interesting. And here, oh yeah, look at this problem, guys. So you get limit as x approaches pi of x minus pi cotangent of x plus pi. So you plug in pi, and you get pi minus pi, which is 0, times cotangent, which is 0. It doesn't seem bad, but if you're forgetting that cotangent is cosine of sine, or 1 over 0. So it'd be cosine of 0, which is 1, or cosine of 2 pi, which is 1, over sine of 2 pi, which is 0. So it doesn't exist. See, this is 0 over 1. This is fine. This one goes here. And this one goes here. Together it equals 0, 0, so you have to do something about it. So what I did to solve this is I broke it up into x minus pi cosine of x plus pi over sine of x plus pi. Then if you take the derivative of the top and bottom, here you use product rule, and it comes up with something manageable. You have a negative sign right here, and never forget that. I broke it up again, so like the derivative of this is x minus pi. Derivative of cosine is negative sine. This is where the negative comes from. Derivative of the inside is 1, so that's fine. And then the derivative of x minus pi is just 1, and you keep cosine of x plus pi. So that's why that stays there. And the derivative of this is just cosine of x plus pi. So I broke it up, and I left this term over here, and I simplified this term to 1. So if you plug in x to here, you get 0 over cosine of this, which doesn't matter. It's just 0 because this is 2 pi. Wait. Yeah, it's 1. cosine of 2 pi is 1. So you get 0 over 1, which is fine, plus 1 right here, and it all equals 1. This funky looking equation equals 1. But my recommendation, if you see tangent or cotangent, always switch into sine and cosine, because that helps a lot. Any questions on that one? Or how I did anything? Oh, hey, Lauren. Yeah. And I will be posting the worksheet I did along with these worked out problems. I think this is the last problem I did. I may have done 8. And then I will be recording these sessions and posting them on a YouTube channel for everybody to see. So how do y'all feel about this model of me doing things? Vanessa and Andy know what I did with the tablet, and it was bad.
Yeah.
Vanessa, you good with this too?
Yeah.
Okay. It's making sense?
Mhm.
Okay. Lauren, you good? I know you joined a little late. Okay, so, I mean, I guess I could try to find a problem. I can't really write anything out. I could try to walk y'all through it, or I could go to a textbook and try to find an example and try to explain that. Yeah, sorry about that, Lauren. I put it on the sessions tab, that way I don't spam the general. That way people can get to the YouTube channel link.
Oh, I have a problem too.
Is it with L'Hopital's rule?
Yeah.
Okay. I mean, I think I could probably like write it out and then scan it in fast enough. I'm gonna stop sharing my screen real quick and see if Andy can share his screen. Do any of y'all have any questions? Hey, homework. Oh, is that the exact problem?
Yeah, that's the problem.
It's because it's got that in the exponent. Oh,
So
Jesus.
here.
Oh, wow, okay. As theta approaches 0 of 7 sine. 7 to the sine theta power.
What doesn't this turn into just 0 over 0 minus 1?
Nope. Sine 0 is 0, right?
Yeah.
What's any number to the 0 power?
1. Oh, okay.
Yep. So
How do I get the derivative of something like that? I don't remember.
I believe it's that rule where it is derivative of a to the x is natural log of a times a to the x times the derivative. Hang on. I can share something. Can y'all see my whiteboard?
Mhm.
Yep.
Okay. D. Oh, this is even worse. Natural log of a times. Hey, why did it do that? Oh, it's ugly now.
If you want, I can write it for you. It lets me edit.
No, I'm trying. I'm trying to get used to this anyways. Yeah. It's about the same speed as the other thing. So y'all remember that rule?
Yeah.
Mm-hmm.
Does that make sense to the other two of you too? Okay.
Would
Well,
the disappear?
do what?
When you simplify it, doesn't the ln disappear?
Nope. The L and the A is a constant number.
Mm.
So you do. Sorry, something popped up on my screen of. Remember, U is a function in these situations. Oh yeah, we can't record whiteboard. I probably should have went to OneDrive. Okay. This is U. This is natural log of A times A to the function of U times U prime. So this is just a function of the chain rule, or just a continuation of it. Is that making any sense?
Yep.
Yes.
Did the rest of y'all have problems with this one too?
I haven't started the homework yet.
You haven't started. Oh, y'all getting free treatment then. Okay. So if do y'all want me to work it out, or y'all think y'all can solve it for a little bit, or?
Do you mind if I go up to the whiteboard and try to see if I can solve it?
Yeah. You go ahead. Let's see if I can stop sharing the whiteboard. Oh, you're writing on it too. Oh, that's cool.
Yeah. 0 of 7 sine theta minus 1 all over theta. So then derivative that, or the Hopital's is.
Apparently, y'all can write on it too. I did not know that. That's cool. But the only thing is, I can't record the whiteboard. So, like, the recording's gonna suck. Can we scroll on this thing?
7 times. If I plug in 0, that becomes ln of 7 times 1 times.
That's 5. That's just a regular constant 5, so it stays on the bottom.
Cosine of 0 is it's 1, right?
Yes.
Okay.
So that's just the answer, literally just natural log of 7 over 5.
Okay. Let me see if that's right. Let's see.
Should be, unless I'm completely wrong. Which has happened before.
Let's see. Ln of 7 or 5. Yeah, that's right.
Okay. James, Lauren, does that make sense the way he did it? Y'all got free homework help, and this should work. Confused in the middle step, so right here. That's L'Hopital. This is him. Yeah, doing L'Hopital. And when if you go over to the left, I don't know if y'all can see my screen. I think you scroll by yourself. You keep the constant. You take the natural. This should be just ln, not lin. I think that's why. Natural log of 7 times 7 to the sine theta. You have the natural log of a, which is 7, times 7 to sine theta, which is the function u, so a to the u, times derivative of u, derivative of sine theta is theta. The derivative of sine theta is cosine theta. Then you took the derivative at the bottom, derivative of 5 theta is just 5. So that's what happened there. You just got to follow that formula. Y'all got any more questions? Y'all could write them on here, actually. This is very helpful. Wait, how big is... Oh, the whiteboard's only so big. What?
I think you have to erase some to add more.
Oh.
Or actually, let me see. I think should be bigger. Oh no, never mind.
Let's see if it does this then. Nope. Do y'all have any questions like the homework or anything y'all can write on here? Or...
Let's see. Okay.
Do y'all have any questions about how class went or my role in class? Because I'm gonna be in there, and y'all can DM me in the chat for Collab Ultra. Y'all can message me during the class.
Okay.
Oh geez.
So I'm gonna be sitting there, bored out of my mind. Oh, what's the other line over there? Was somebody else gonna write something? Is that 9? Is that 9 over x or a over x?
Oh, it's A.
Okay. And a cannot equal 0?
Mm-hmm.
Well, anything over infinity will be 0. That's the... Oh, is this multiple choice?
Yep.
Oh crap, hang on. Didn't mean to do that. That's obviously not going to be 0 because that is 1 plus a is... Anything over infinity will be 0. What are these options? Is like a this and then a this?
Oh no, it's like A, B, C.
No, like what does this mean? Like 0 times infinity? Infinity, is it the domain or?
Oh, here for this one.
Yeah, like what do these mean? Like this is 1 to infinity. This is the definition of e. The limit as 1 plus a over x all to the x power as x approaches infinity equals e to the x.
It's asking which one of these ones is the intermediate form.
My money's on C.
No.
C is wrong.
Yeah. Oh wait, I'm sorry. That's D. I think I skipped one. You're right.
Yeah, 1 to infinity, because that's the definition. The definition of 1 to infinity is e. When you take the limit, it's all sorts of funky. Do y'all remember that? Where she put up that? I think it was another one of the rules. She just calls it rule this, rule that. I'm not the biggest fan of all that, but. Why'd the whiteboard get smaller? I don't know what happened. No. Okay, I think I'm finally figuring out how to use this. Do y'all want the whiteboard back up to ask more questions, or because we got 25 minutes? And also, how's my audio?
It's good.
Because this computer has always had a problem with the sound port. It's always been bad. Okay.
A number to the infinity, is that equals infinity?
What do you mean?
Like if it's 2 to the infinity?
2 to the infinity?
Mm-hmm.
2 to infinity is infinity, yeah. 1.01 to infinity is infinity, for that matter.
Okay.
I don't get any. I can try to find another problem. Is there anything that y'all, it's been a while since y'all been over, and y'all want to recall, like do a problem or something? I can find something in the textbook really quick. I won't be able to write anything, but I can try to talk y'all through it. And I could find an example problem and explain it in human words and not math textbook words. My computer fans are going loud.
I guess like continuity. I don't know if anyone else needs help on that.
What specific part about continuity? Like the 3 different
Like,
types?
yeah.
2.5, 114, so it'd be about 130. Let me see if I can find it. Oh, what you got, Vanessa?
Yeah, for continuity, like sometimes I have trouble like looking at the problem and figuring out if it's continuous or not.
Okay, let me go back to the thing. That's what it is. So continuity. I'm going down to it in this textbook. I prefer a Web of Science textbook, personally. Okay, let me get back over here. Screen share. This. All right, can y'all see my screen?
Mm-hmm.
Yep.
Okay. Apparently, I can give y'all control to this. I don't know. Oh, that's cool. Let me. I haven't tried to give y'all control. Oh, it went away. No. There was something up here. Oh well. It's too late. But so for continuity, so for something to be continuous, it has to be defined at every point in its domain. So like you have to be able to draw at every point on this graph and not pick up your pencil or pen. That's what it means by defined. So no holes, no asymptotes, no nothing. Does that make sense?
Mm-hmm. Like, can you do it like without drawing a graph? Like, because for some equations, you know how sometimes like I don't even for the different like theorems we did, like you need to see if it's continuous or not. I don't know if that makes sense.
Okay. if there's anything in the denominator that's not just a constant number, odds
Mhm.
are it's not continuous. Unless it's an x squared plus 2, then it's always continuous because it'll always be greater than 0.
Okay.
It'll be 2 or greater, but we're going to try to find a problem and try to work it out on the whiteboard or OneNote or something with a pencil or with a computer mouse. ArcSine, wow, okay, I don't want to do that one. Yeah, WebAssign gives harder problems. Okay. So, you mean like number 12, Vanessa?
Sure, yeah.
Or would you rather something else?
I mean, anything is fine. That would be fine too.
Okay, here's a good one actually. A square root function. We'll do 13 first. Square root function. Where is the square root of x defined? Anyone?
Where is what?
What's the domain of the square root of x, and where is it defined?
When it's not negative.
Yeah, so from 0 to infinity, right?
Mm-hmm.
Okay, so from 0 to infinity, the square root of x is defined. So it's continuous from 0 to infinity. But as soon as you go a minute number to the left of 0, it's not defined anymore.
Mm-hmm.
So there is continuous from 0 to infinity. But when you have, say, the square root of x minus 4, or skipping this problem,
Mhm.
it still has to be greater than 0. So if you solve this for 0, the domain x equals 4. So the domain has to start at 4.
Right.
So it exists on that whole point. So that when you go back to the three things, it exists, is continuous, or that's the three things of continuity.
Okay.
I'm sure y'all can't see this at all. Microsoft Teams does not do a good job at updating their stuff. Or their netcode is really crowded right now or something, because literally everybody and their mother's on it. So you had to find the limit. Okay, you got to use the limits. So f of a is defined at every point of the domain. So at first you find what's defined, and then you do the limit. And if the limit exists, because the limit can exist and f of a not exist because there could be a hole. So step 1 is make sure that f of a is defined at every point. Step 2 is make sure the limit exists. And step 3 is make sure the limit equals that. I wish I had a good Surface or iPad or something. I could show y'all. But in here, that's supposed to be equals. Oh, see, it's possible it was equals there. Okay. 2 times. Okay, you got to solve this one. When will this be negative? 3b squared plus 1. When will that be negative?
Never. It won't be negative.
There you go. Okay, but these specific particular problems use a definition of continuity and the properties of limits to show that it's continuous. A. So if you plug in 1, you get 2 times the square root of 3 plus 1, which is 2 times 2, which is 4. So it exists at A. Take the limit of this function as A approaches this, or as V approaches A, and you get 4. Then you get f of A plus the limit as V approaches A of this, and you get 4. Therefore, it is continuous at A equals 1. That's how you do it. You follow those 3 steps and show your work to prove it. Is that clearing anything up, or did it make it worse
Yeah.
because I can't write anything?
No, I get it.
Okay. And up here, I don't even like these. You're just plugging in a point. So you get a, which is 2 squared, which is 4 plus 10, which is 14 over 5. So g of a equals 14 over 5. The limit as g of t approaches a is the same thing, 14 over 5. You're just plugging in a.
So you basically, sorry.
Do
No,
it,
you
Andy.
go.
Go ahead, Vanessa.
Oh, so basically you see the domain when you like try to find if it's continuous or not for a problem.
Yeah.
Like in the denominator, like what would make it 0? Yeah.
What would make it undefined? Yeah, set the denominator equal to 0.
Right.
That's the gist of it.
Okay, so that was my main problem. Yeah, I get it.
See down here, if x equals 2, -2, if x equals -2, because if you solve this for 0, it doesn't exist. But since the domain doesn't exist at -2, it's continuous all the way up until that point.
Okay. Yeah, that was my question.
Yeah, if this had a bracket like this does right here, if there was a bracket right here, then this would not be continuous. But since it has that right there, it does. Anybody else have any questions about any of the older topics? Doesn't have to be continuity. It could be something else.
I had a question for like limits.
Okay.
If the limits, if you can plug it in, you don't have to find the derivative of the equation.
If you plug it in and it works, don't do anything else. Because if you take the derivative after that, you'll get an incorrect answer.
So only if it doesn't work, then you have to find the derivative?
Only if you get 0 over 0 or infinity over infinity. Indeterminate forms. That is the only time you use L'Hopital's rule. And I repeat that thoroughly. That is the only time. And then if you start doing L'Hopital's rule and you get down to where you get 0 over 0 after taking derivatives, you did something wrong. Somewhere along the line. So, anybody else? Any questions? I got a whole textbook that I pirated offline that we can go through. We can go over hyperbolic functions. We never went over that in class.
Okay.
I don't like Taylor. I don't like the word Taylor after calculus 2. I could try to. I know you were talking about graphing. Well, the calculator is the mean value theorem. I probably should have made problems over that. Actually, I think that's what I'll do next week is mean value theorem. I'm gonna try to go over some of that. Is this what y'all really want to know? What you went over the week before we got kicked out? How do derivatives affect the shape of graphs? Anybody have any opinions on that? Or are y'all just bored because I didn't plan enough?
No, I mean I always have a problem with graphs, so why not?
Okay, I can't draw anything. It's probably what should I. That's
but I'm not sure if others want to do it too.
Oh, trust me, they do. That's the hardest part, really. Until you get to optimization is the hardest part about calculus 1. And if you can do that relatively easy, it'll be fine. When y'all get to optimization, y'all better come back to me because those problems are ridiculous. And she doesn't do the best of jobs of explaining. I mean, I think she explains a bit better when she's right here just working out problems. But I forgot what problem it was. Okay, how derivatives affect the shape of a graph. This rule right here is important. If the derivative is greater than 0 on the interval, then f is increasing. If the derivative is less than 0 on the interval, it's decreasing. Do y'all remember the velocity problems from way back in the past?
Oh my god.
when we still had a class to go to.
Yeah. Do you think that's gonna be on the test, like a 10-point question about finding all the?
Oh God, yeah. Oh yeah. She's gonna make you graph it. Like what you do. Okay,
Do, do we have to find acceleration, velocity for graphing, or
it's the
that's
same concept, except here you're actually making a graph. See right here is they differentiated. Uh, if y'all can't tell, I like this textbook better. They differentiated this function and then came up with this. Then they factored it and got this. They got at every point x equals 0. Because then the first derivative or the initial function is changing direction from increasing to decreasing. Does that ring a bell or make sense to everybody?
so they found the derivative and then they factor it out, and then can you repeat the last part?
They factored it and then they set it equal to 0.
Okay.
And they found at every point where the derivative equals 0. So I don't do it in the chart. I prefer to do it on in a number line fashion, like they have it up here. See right here, when this is less than -1, it's negative, 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 negative. Oh, this is how they did it. Well, I'll see what they did. So they have it factored out. Why didn't they put it down here? Let me try to. Yeah, that didn't work. That really didn't work. What number? How far did I go down? Oh, here we go. They've found this factored form right here. So what makes it easier? They just plug in -1 to 12x, and then they -1 to 12x, and when you plug that in, it's negative. And when you plug in -1 to x minus 2, it's negative. When you plug in -1 or a number less than -1 to x plus 1, it's negative. And a negative times negative is negative. And then when you have a number between -1 and 0, you plug that in, you get negative, negative, positive. And since you got a negative times a negative makes it positive, and then you multiply a positive times a positive, you get positive on that interval between -1 and 0, like that. And this isn't even the second derivative. This is between 0. You plug in a number between 0 and 2, so I'd plug in 1. So 12 times 1 is positive. 1 minus 2 is negative. 1 plus 1 is positive. Positive times a positive is positive. Positive times negative, negative. So it's decreasing on that interval. I'm sorry, I know y'all hate me teaching from a textbook because I hated my professor who did it, but it's the best I can do. I can't write with a mouse. And you plug in a number greater than 2, you get all positive. So it's increasing from then on out. So from this, it's decreasing from -infinity all the way to -1. You'll see from -infinity to 1. Or -infinity to -1. This is -1 right here. Then it's increasing from -1 to 0. Remember, because we found that it was positive at that point. This is the original graph too, guys. And then from 0 to 2, all the way down here, is decreasing. And then from 2 to infinity, it's increasing. Is that ringing a bell or making any sense? Am I making sense? Or is this where y'all get lost?
So is that the derivative, the second derivative, like the 12x?
No, this is the first derivative. This is all the first
Okay.
derivative. Yeah, we hadn't even got to the second derivative yet. This is just the first derivative. So your critical points right here would be where x equals 0. All right, derivative equals 0, and then what you do is you plug the critical points into the initial equation. You plug into the initial equation, and then you could find these values so you know where exactly to change it. Because what you're looking for is a general shape of the graph and specific points. That's what she's looking for, at least.
Okay.
This is the first derivative chest. Y'all can read back over that. I want to get to the second derivative.
Second derivative is acceleration, right?
Yeah, essentially. But what does it tell you about the general test, the general graphs?
Slowing down.
No, what does the second derivative tell you about a graph?
The concavity.
Yep.
Oh,
If it's
okay.
positive, the concavity is up or down.
And then if it's 0, that's when it switches, right?
It's an inflection point, but oh yeah, here it is.
Well, I was wondering, I was doing one of the homeworks for first derivative to find the like uh absolute maximum and absolute minimum or locals.
Oh, Thursday. Come back Thursday. I went through 6 of those problems. So
Yeah, can you just divide the numbers you got from the first derivative and use that as the inflection point?
No.
No.
No. Sometimes, but no. You have to take the second derivative.
Okay.
There's always special cases for everything in math, but the only concrete way is to take the second derivative. I wonder. No. There's the second derivative test. There's defining the local min and max. Yeah, I don't like this test. I just like, you could do this, which is what's recommended. But what I've always done and will continue to do, if the first derivative is changing from positive to negative, it's a local minimum or local maximum because it's increasing and then it starts decreasing. So that's a local maximum. If it's changing from negative to positive, it's a local minimum because it's going down and it starts increasing. So that's a minimum locally. But this one does, this one solves for quadratics because when at a quadratic equation, when the point is at the vertex, is changing from, well, it's still changing from negative to positive. So it still works there. But this solves for those problems when you get a positive and a positive. So if she asks you what the second derivative test is, this is it. And if she if on a test situation, use this. On any other situation, just use the first derivative. Second derivative just helps you to graph. Okay, curve. And this is a type of problem where you would this right here is where you have to find everything to graph it because none of us know what that graph looks like. We know where it hits 0. It hits 0 at 0 and 4. But when you take the derivative, you get x equals 0 and x equals 3. For your critical points, you take the second derivative, you get x equals 0 and x equals 2. You see why you had to take the second derivative, Andy?
Yeah.
So prime with 0 and 3 equals. Oh, this is doing the second derivative test right here, actually. Do y'all like y'all's textbook or this textbook better? Or
Probably
no
that
textbook?
we're showing right now. I haven't been able to understand our textbook at all.
Yeah, Pearson sucks. I mean, Pearson for engineering, like civil engineering, is okay. Like statics and strengths. After that, it just sucks. So they found where the first derivative equals 0, which is 0 and 3, and they plugged it into the second derivative. And since it's greater than 0, then from negative infinity to 0, it's positive, it's upward. Because since it's 0 and since the first derivative is 0 and greater than 0, there's a local minimum at this point. And since it's greater than 0 and it equals 0 here, so I don't even know what, that doesn't even get covered in the second derivative test. F prime 3. What do you mean that's greater than, that's 0? And F3, so it's a local minimum. See, this is a local minimum right there. The expression shows that f decreases to the left 3 and increases to the right of 3. Since the second derivative of 0 equals 0, the second derivative test gives no information about 0. And since it gives no information, since it gives no information, it tells me that it's not a local min or a local max. So what that probably means is an inflection point, as you can see over here. So when you get no information from the second derivative test, you more than likely have an inflection point. Is that making any sorts of sense? What's an inflection point, Andy?
That's when right when it's making the shift to be concave up or concave down.
Yeah, when there's a shift in concavity.
Yeah.
So that means there's an inflection point. And a lot of times an inflection point comes around when the second derivative is like 0. No, if you get x squared or if you get x minus 3 squared, there's probably an inflection point at x equals 3. Not in this case, but if you get it squared in the first derivative, it's more than likely what happened is there's an inflection point right there. We are actually out of time. Do anybody have any other questions about what I'm doing? Anything about everything else?
Has she told us yet, like, how the test is gonna be? Like,
No.
all right, okay.
She has not told me anything either. I've emailed her, so I can't give any information about that.
Okay.
So I'm just gonna be in there, and y'all can message me in the collaboration things. Probably if y'all have any immediate questions, I'll be sitting there bored. So yeah, and I'm gonna try to do these more. I think what I'm gonna start doing is making y'all work out a problem, then I'll switch over to something and show y'all the steps. That way y'all actually get practice rather than me just flying through something, because I don't think that helps y'all that much.
Are you thinking of getting the Surface Go or just like a regular
The
tablet?
Surface Go with the keyboard and the pen is $750 because they're out of the cheap one. So I don't know. I mean, I'd like it, but yeah, it's a lot, isn't it, Lauren? So I can't justify spending that much money. If I didn't have my nice laptop, I would have went ahead and got one, but oh well. So my ODE professor gave us a test and then went over the entire weekend in differential equations, and everyone is so confused. Like, the problems are so abstract and hard. He never went over anything as hard as this in class, but that's just a personal problem. Do y'all have any more questions? James, you've been quiet a little bit. I don't know if you've been trying to do problems or whatever.
I think he doesn't have a mic.
Oh, no, but he's been in the chat.
Oh, okay.
If y'all don't got any questions, I will see y'all, or I will be in the classroom tomorrow on Collaborate Ultra. And I'll be here Thursday, and I'm going to be doing the local mins and max and the absolute mins and maxes on the domain. And y'all can bring by some questions.
You have essay sessions on Wednesday, right?
No.
No?
No. I may switch this Monday one or anything. I'm keeping the Friday one because that's when y'all just bring home more questions and I can help y'all out.
Mm-hmm.
I'm going to keep the Thursday one.
The test is on Thursday, right?
I don't know. Y'all can ask her when y'all go back in the classroom tomorrow. So that's what I would do. But yeah, I don't know. All my professors gave me a new schedule. Like, they printed out a whole new schedule. So.
All right.
Well, I will talk to y'all later then. Thank y'all for coming.
Thank you.
Bye.
Bye.